Hello everyone, and welcome back to a new episode of Silicon Zeros. We just, in the last episode, completed this first tutorial segment, which I guess is called the first board. That was what the achievement said, we completed the first board. So I guess that there's going to be a series of blackboards that we can access through this stuff down here. So let's move on to board 2, the CPU. And looks like we have, unsurprisingly, a lot of... yeah, this stuff changed. We upgraded our coffee machine into a microscope, I guess. Okay. And, of course, a bunch of other things, but that's the most noticeable. Okay, cool. I guess we'll just get started on palettes, see what's up. Hey, Laszlo said something to me earlier that gave me the idea for this. The palette. It lets you save groups of modules between puzzles and place them elsewhere. Well, that's nice. I've gone back and enabled the palette for every puzzle that you can place modules in, including ones you've already finished. You can only use the palette to place the module types that are available in a given puzzle, but you can save anything in it. Right here, you can only place modules to the palette. See if you can use that to recreate the counter machine here. You know, set memory slot 0 to 0, 1 to 1, and so on. Okay. So where's my... palette is on 4? I don't have any things. Okay. Drag select modules in the main editing pane before what? Okay, so I can't place things here, and I can't drag them into this either. So I think that means I have to go to a different puzzle now and grab this stuff. It said drag select. I'm confused. Copy. There's a palette for... Can I just press, if I press Q? Yes, add selected modules to a new palette group. So now I have group 1. Can I right click on this and name it? No. Alright, fine. Well, escape a few times, I guess. Go back here. So it's good that we're learning this reuse. So this is a writer. Okay, so I want to place... Hello? Oh, W, right. Writers are not available, but I can place the other stuff. Fine. And we're just going to do this, which I believe is how things were wired up before. Yeah. Okay, cool. I'm glad there's some modularity on, like, you don't have to redo every puzzle from scratch. If you find something useful, you can save it. Okay, here's Jack. That's our marketing guy, right? Our businessman. Look, there's no time for whatever garbage you were building. You people have been spending so fast there's just a few months of cash left. We need something marketable ASAP or Zerocom will go kaput. Capiche? Wow, alright. Let's get to it. Alternator 3. Alright, well, VREF sounds more interesting. I would like to learn about, I assume this is like indirect memory access or something? I'm gonna meet our investors soon. They make me somewhat nervous, and I would like to have something to show them. Can you replace each slot that contains the location of another slot with the value held in that other slot? Readers produce this empty nothing dash thing when reading from empty slots. So that's the same as like if something isn't wired up at all. Recommend experimenting to see what other modules do with it. Okay. So I guess we're going to want to read through memory. So, well, let's grab this counter here. We'll want some of it. In fact, what we kind of want is to not include this in our counter. So let's delete that. And delete that as well. And now we've saved just the counter. Okay. So this way we're gonna use this to scan through memory and then figure out like what to do with what's there. So I guess let's just no, not right. Go away. We want a reader. Okay. So it produces a 10 when there's a thing there. But I would like to temporarily here know what happens. Oh, give me like a 5 or something. Okay, so we get this dash. What happens if we wire that up here? Well, of course it doesn't change anything. Very funny. Alright, well, let's just sort of wire this up, assuming that it's going to do the right thing. And when something interesting happens with a dash, we'll find out, right? I would guess that if a writer is not provided, if a writer is provided a dash as its write value, it probably just doesn't write, which is fine with me. With the value held in that other slot, so it would be a little awkward if like 2 held 0 or something, right? Because then we would go back. I don't know. Whatever. So this is the new value we want to read a slot. This is the number of a slot we would like to read. So let's just do that. And then we want to make a writer for this same slot that should write this. Yes? So, like, this looks about right. I don't know what's going to happen when we get to a slot, like when we read slot 1 and there's no, and it points to -1 where nothing exists. I assume it's going to be fine, but I don't know exactly what will happen, so let's just put it into the simulator and run one step here. So, great. It did what we wanted. And now it's read a -1 and said that's the slot. It read a dash, there's nothing here. And when we say to write that, indeed it doesn't write anything to 1. Oh. On the other hand, this is not advancing anymore. Why not? Oh, we didn't wire this back up. Okay. Yeah, that's pretty important, I guess. Alright, let's go. Well, I guess we need to fix our palette, huh? And grab just these guys. Save them to the palette. And now if I place... Does it come out right? No. Oh, because they're still not wired up, you idiot. What? Oh, wait, no. They are wired up. I don't want that one to go there. I want this one to go here. Oh my gosh. Wait, what happened to my palette? I thought I had a thing there. Did I just delete it? I bet I did. This game is so hard. I don't know how to, like, use buttons. So save that. And if I now said to place it, yeah, it looks wired up okay. Okay, so let's go back to the test and see what happens. So, as before, we correctly write 30 to slot 0, and then we read a -1 from slot 1, and as a result, we do not write anything. Great. Now when we're reading slot 3, we look into slot 1, and we see a -1, and we write it. Okay, so I think this is done. So, yeah, readers produce a nothing, and writers, when they get a nothing, don't write anything. That makes sense, of course. The investors have given us a bunch of money, and they're worried that they want it back. This is what I hired Jack for. He seems like a sharp man. With you working together, Zero-Com will surely never have to worry about money. So I want to go and check this out and see what happens if we ever write like a nothing to the latch. How do I make a thing be connected to nothing? There we go. Well, what I kind of want, I want there to be a value other than 0 here, and then put a nothing in, but that's a little hard. I don't know. We'll figure that out later, I guess. Zeros. Okay, bud, here's the plan. This company is going public in 2 months. Before that, we need something we can sell. Your pals want to build all kinds of fancy trash. I say that's dumb. Stick with little gadgets you can actually build, like a gadget widget that replaces all ones in memory with zeros. You get that done, we'll see about what else you can do. I gotta say, Jack seems like he's being set up as the villain after everyone else was so nice and accommodating, and Jack is very rude, and no one has said anything at all about his mental temperature, which to me seems a bit off. Okay, so we're gonna need this counter thing again, of course, to scan through memory. No. Well, we'll want a writer eventually, but what I meant to get first was a reader. So we can get a thing. Replace all ones with zeros. Oh, I have a new module. Input selector. Takes several inputs and outputs the selected one. Okay. So we feed it multiple inputs. Okay. So I can do this. Ah, but I actually want to wire it up. Wait. If it is... Okay, so we'll put a 0. Wait, what? No, this... I want 2. Okay. So I can make as many input, or a large number of inputs. I can configure how many ports this has, but I can't put numbers into the ports. I need to use these guys to do that. So what I'm going to do is make, let's see, replace all ones with zeros. So one of these is going here. So we need to have access to both the old value and a 0, right? So I'll just put a 0 here and wire it up to this. The idea being, is this right? Read 1, 1, okay. Oh no, I don't want to wire it up to this. I want to wire it up to this. So this is the value that was read from memory. And this is the slot number to use. So if the value that we read is 1, we will output this. Otherwise... Well, so here's the thing. I don't know what's going to happen if this value is like 7. Right? Are there any like really... Yeah, there's some very large ones here. So I don't know what this thing is going to do when we feed it a nothing. Yeah, it outputs nothing. Oh, which is fine, right, because in that case we just won't write anything and we'll leave what was there alone. So, interestingly, if we could give this just 1 input, which seems a little bit silly. No, because we needed to have an input numbered 1 that we can connect this to. Okay. So just like that, please. Hello? There we go. Connect that up, and give me a writer. So it's a nice little routing thing there. We'll move this a little further down just so that it, I don't know, this is all messy, but that's life. Okay. So that's the idea, is we scan through memory with this counter, we read the thing, and we use that to decide whether to read a 0 or to write a 0 or to write nothing at all. We replaced the 1 with a 0, and we left the 28 alone. I'm convinced. Huh, you actually built it. What are the odds? Well, get your button gear, you've got a lot more to do. That was a fun one. There's no way we could have really optimized this, right? I don't think so. I feel bad about needing this 0, but I think we do in fact need it, so... Alright, back we go. Show me about multiplexing. Are you liking the input selector? I was going to introduce it to you, give you some useful tips. It's rightly called a multiplexer, did you know that? But a certain someone was too busy running his mouth. Did he even tell you to right-click selectors to configure them? I don't know if he did, but I tried it anyway. Anyway, store 0451 in memory slots 0 through 3. Okay. What do I need a memory multiplexer for? Is what I want to know. So what is this? I have a control module, right? I had that before. And I have a latch and an adder. And numbers. I see, but the point is that I can't make more than one writer. Okay. Well, give me this guy. That's the slot we're gonna write to. And I'm gonna need also an input selector with 4 values, I guess. And we'll do this as well. And I guess just like, let's see. Wire this up to here. And we're just gonna have to put in a bunch of dang numbers here, right? So we want, well, actually we don't need this one, right? We've already got a 0. We don't need, actually we only need 2 of them, I believe. This one will have a 0 at the time that we need a 0. We can reuse this one, and then we just need to wire these 2 up. Oh, that looks much better. Yeah, good reroute there. Okay, so we want to put a 4 here, and a 5. Oh, I think I said 3, but it was a 5. Okay, cool. I suspect that PleasingFungus made a 0 be the first input on purpose, so that if you were clever, you could avoid needing to use any zeros and just use this one. But none of the other 2 happen to line up with any numbers you have lying around, so I think you do need numbers for them. Great. That Jack just came by. As far as I could see, he was here to slap my butt, call me sweet cheeks, and ask me out for drinks. When I turned him down, he called me a very different name and swore he'd have me fired. What a charmer. I'd worry about that more if Laszlo was hard-hearted enough to fire anyone. But if he was, I could think of a better candidate. Yeah, so, okay. We're being beaten over the head with Jack being the villain, which is fine with me. Let's go check out Alternator on our way to 3s. Oh my gosh, 4. 4 stars. Alright, well, we'll leave that. You met Jack yet? Nice guy, right? So polite, so charming. I like Alicia. Very, understated. He showed up and started shouting, told me to work on this machine that starts at slot 0, sets even memory slots to 1 and odds to zeros. I said I don't do hardware, but he'd already left. If you want this, it's all yours. Okay, so do I have any, like... I have a subtractor? That's interesting. What am I going to do with a subtractor? Huh. And how am I going to take evens and odds? This is interesting. I don't have any clever ideas about this one at the moment. So what kind of weird subtraction tricks can you do? Like... I don't... Oops, I think I bumped my headset there. I'm thinking there might be something clever to do with having two latches, one of which... One of which runs at like a period of 2, while the other one runs at a period of 1 somehow? Yeah. If we could wire up, if we could connect two latches to each other, and have them start with a cycle of like... Add 1... Okay, I think that's the idea. I'm not sure exactly how it's going to work yet. So, my thinking is, the last of these latches will be stored up to what to write. This counter is stored up to where to write it, of course. I should make this more compact since I'm using it over and over. So let's just do that now. Fine. So right, what I'm thinking is I take a subtractor. No. Well, I'll need a subtractor eventually, but I wanted an adder first. So I'll take this 0. We'll take whatever was here and add 1 to it, which should always be 0. I don't think this is the right way to do it, but I'm going to go ahead and follow through and see what happens. My thinking was to, on the way back, subtract 1. Right, like this. But I think that this just means that this is going to have a 1. Is this right? What's going to happen here? This will output 1 on the first time step. So we'll write a 0. First of all, this is backwards. We're doing it the opposite of what we meant to do, but we'll send out a 0 on the first time slot. On the next time slot, we'll send out a 1. And then this 0 that we wrote will have been sent with a -1 here. I think this actually sort of works. Wait, it sets even memory slots to 1. Okay, so we definitely cannot wire any of these latches directly to the output, because they're always going to output a 0 at slot 1, which is wrong. Or, at time unit 0, they'll output a 0, which is wrong. We need to... So what if we just do this? This actually might be okay. I would like to step through and see what happens here. So, I'm going to write a 1, and then how do all these inputs change? Huh? I can't really logic through what's happening here, but it looks correct. Huh. Well, I wish I understood how I did that a little bit better. Anyway, thanks. God only knows what this machine is good for, but it's one less thing for Jack to scream about. He'll keep screaming anyway, but it'll be about something new. So, what exactly happened here is that we have... Over the course of every 2 ticks, we add 1 and subtract 1. So, we're not increasing without bound in any direction, we're just oscillating between 2 different values. And here, we grab the value whenever it happens to be in the right phase for the output that we want. Okay, that seems simple enough, I guess. Let's do instructions real quick, and then I believe we will be done with this episode. Shh, be very quiet. I don't want Jack to hear us working on this. We're trying to build a machine that can execute instructions. To execute instructions, you read them from memory and then do what they tell you. Oh my goodness. Right here, you should decode and execute the 0mem instruction in each slot. You can mouse over instructions in memory for more info. 0 memory set. So, okay, there's an instruction. This is a wrinkle I did not expect, that we have like a microcontroller thing here that actually there's not just wires and chips. There's assembly instructions that you can execute as well. Okay. So there's an instruction called 0mem that just takes this last argument. Fine. Source target dest, huh? Fair enough. Okay, so we've been given a new thing here called instruction decoder on E. Okay. So what we need to do is... Okay, so we 2Q. We say we're gonna fetch. Okay, I need also. No, go away. Whoa, game crashed. Assertion failed. Paste buffer.cpp. I don't think you guys can see this. I would like to copy this message and send it to PleasingFungus. Alright. Well, tell you what, guys. I'm not gonna go to the trouble of like restarting the game and everything. We hadn't even really started this puzzle, so I'll just call the end of this episode. That's early access for you, I suppose. And we'll get back to it in the next episode. Thanks for watching, and I'll see you next time.